naturally.
Hello everyone, welcome. Today we're going to do some work on sectors and segments. Now this is not a heavy going area of mathematics, but it's one where you've got to know the terms and you've got to be able to just pull out the right formula at the right time. Look at our diagram here. This has got all the things that we need on here. So looking first at A, B, which we would call a chord. Any line that goes from one side of a circle to the other, not necessarily through the centre, but just one side to the other is called a chord. Now one special chord is the one that would go through the centre of the circle to the other side, and we call that the diameter. But any chord is just from 2 points on the circumference of the circle, join them together. When we do create a chord, we also split the circle into two parts, and we call it a minor segment and a major segment. You can figure out what that means. If it was through the middle, then we wouldn't really have a major and a minor segment. We'd have two half circles rather than a major and a minor segment. But all these formulas will still work the same if you really needed to do that. The chord also creates a minor arc and a major arc. Again, follows with the segment naming there. The other thing that we've got to be aware of is this sector idea. A sector is from the centre of the circle to 2 points on the circumference, and again we form a minor and a major sector. So make sure that your labelling, your understanding of those words and what they mean is strong, because otherwise the questions will trip you up when it asks these slight differences between the words and you get the wrong one. Let's look at a sector first. Now I've just drawn a small little diagram here, not particularly accurate, but we've got our angle in here. Now that's really one of the only pieces of information that we need to work out a sector. We need that one and we need the radius of the circle. If we've got those two, we're sorted. Looking at this formula here, if I cover over that part there, all that really is the area of a circle. So all I'm saying is I want theta 3/60ths of the circle, which is going to be that section there. Now, of course, if I wanted the major sector, then that up there would be 360 minus theta. Or I could work this out and work out whole circle area, take one away from the other. So there's a couple of ways we can go, whatever's easiest for you. Probably easiest to work out this angle first if you needed the major segment, major sector. If you needed the major sector, work that out first and put it on in. If you need the minor one, put it straight on in, number crunch, out we come. Now with this one here, and with all of these through here, we're talking about an area. So if we're talking about an area, then our answer needs to have centimetres squared, centimetres squared, metres squared, something like that. If the question doesn't give you any dimensions, put units squared on the end. That's telling the marker, I understand that there's units here, you haven't given them to me, but I'm telling you that they need to be there, and I'll just put units squared. When we're talking about an arc, so now we're talking about the distance around the outside. The arc is the distance around the outside. Well, it's a very similar formula to this one here. The difference is instead of the area formula here, I've put the circumference formula here. So I'm really just working out alpha 3/60ths of the circumference. And that's going to get me this dashed line around here. Similarly so, if I needed the smaller area there, 360 minus, and we'll be on that one. Now I did a little simplification here because I saw a 2 on the top line, 360 there, so you might want to go with that formula if you prefer. I'd probably suggest not, because this is more descriptive. You're taking alpha 3/60ths of the entire circle, but some may prefer this. Similarly so with these here, you may actually prefer to put them into radians, and we can do that as well. So you can replace the 360 here with 2 pi's, and then you'll notice that a number of things will start to cancel, and you may prefer to do that as well. The last one over here is finding a segment. Now I've put a minor segment here because we can find the major segment, but it's just going to be a slightly different formula to do it. This diagram here, what have I got? This black area here, that's the area that I want, because that's my segment, that's the minor segment. But I've also added in these red lines here because I actually need to work this out, or part of this as well. So what I'm going to do is I'm going to work out the whole area here, and you notice I've got area of a sector. I'm going to work out this whole area here, and then I'm going to subtract away that triangle area there. and that'll leave me with just this here. So the area of a sector, I've already got that back over here, so I don't need to rewrite that formula. But I need to know the area of triangle ABC in here. Well, previously we've done area of a triangle using sine, half AB times the sine of C. Well, that works pretty neatly here. Half AB times the sine of C, and it's neat that both of these are radiuses, so this is just going to be r squared here. And my area of the sector, as I said, I'd already done that here. So all I've updated is just the angle naming. So I'm here, and then I'm subtracting away that area of the triangle, this one here, and that'll leave me with just this black area here, which is what I was actually wanting. Now, if you wanted to do the major segment, I would probably still work this one out first, and then do the whole circle minus that area that I've got, and that would get me this area here. That's going to be the easier way. It seems a little bit complicated. Aren't I doing another calculation? You are, but probably easier to work out this one, and then it'd be pi r squared minus that answer that you had there. Hope this explanation's helped you. See you later.